Hello, this is Mr. Mola for lesson 1-4, solving absolute value equations. All right, so absolute value, let's take a look at what absolute value is before we talk about the equations. So absolute value, if I have a question like this, the absolute value of -3, absolute value of +3. Absolute value is the bars around the numbers. So absolute value of -3, I'll tell you is 3. Absolute value of 3 is 3. Okay, so you might just think of it as an easier way. Absolute value cannot be negative. And the reason absolute value cannot be negative is because it's your distance away from 0. You can't have a negative distance. You can't tell someone to go -5 feet. You might use like left or right or backward or forward or north, south, east, west. But -5 feet isn't really an option. Okay, so let's say that I'm at -3. And I'm at +3. Here's 0 in the middle. My distance away from 0 to +3 is 1, 2, 3. My distance away from 0 to -3 is 1, 2, 3. I'm still 3 inches, 3 feet, whatever it is, away from 0. We wouldn't say I'm -3 feet away from 0 or I'm +3 feet away from 0. You would just say I'm 3 feet away from 0. So absolute value measures distances, and distances can't be negative. So if you look down at exploration 2, it says consider the absolute value equation. The absolute value of x plus 2 equals 3. So on a number line, locate the point x plus 2 equals 0. So going back to the stuff we did last Friday, we're just going to solve this. X plus 2 equals 0. So I'm going to subtract 2 from each side, subtract 2 from each side. 2 minus 2 is 0. 0 minus -2 is -2. So I'm going to locate the point. X is -2. Then it says locate 3 points that are 3 units from the point that we found. What do we notice about those points? So I'm going to notice 3 to the left. So 1, 2, 3. So now I'm at -5. And I'm going to go 3 to the right. 1, 2, 3. So now I'm at +1. And the thing that we should notice is those are the answers for our problem. Most absolute value equations have 2 answers. And we're going to go ahead and plug in these 2 answers to check it. So first I'm going to try -5. So I end up with x is -5. So instead of x plus 2, I'm going to put -5 plus 2. So absolute value of -5 plus 2 equals 3. Let's see if that's true. -5 plus 2 is -3. Still absolute value. Absolute value of -3 is 3. So we end up with 3 equals 3, and that is true. Now let's look at the other point. The other point we found was 1. So I'm going to do it down here. So instead of x plus 2, I think x is 1 now. I'm going to do 1 plus 2 equals 3. 1 plus 2 is 3. Absolute value of 3 is 3. So 3 equals 3. So we're right. The 2 answers for this problem are -5 and +1. Both of them make this equation true. So -5 plus 2 is -3. Absolute value of -3 is +3. 1 plus 2 is 3. Absolute value of 3 is 3. Okay, so that's kind of one way to think about it. I'll explain another way here in a second. If we look at the example problems. Okay, so I have 3x plus 12 equals 0. This is one of the times that we're only going to have one answer here. Okay, so I'm just going to solve this like a normal problem, and I'm in fact just going to forget about those absolute value bars because that's what we do for half of this math today. So 3x plus 12 equals 0. So going back to what we did last week, -12 minus 12. 0 minus 12 is -12. Divide both sides by 3. -12 divided by 3 is -4. So this is one of those weird ones that only has one answer, and it's because that's a 0. There's no such thing as -0, so we can't set up our equation with 2 problems. Okay, so if you look on here we have 8. There is such thing as a +8, and there is such thing as a -8. So when we have this, the first step we need to do on solving an absolute value equation is making sure our absolute value is by itself. Okay, y plus 2 is by itself, so now we can write our equation. So I have y plus 2 equals 8. And remember, absolute value is also the negative, so we could be 8 units to the left and not 8 units to the right. So I'm going to set it up another way and do y plus 2 equals negative 8. So those are our two equations for today, or for this problem. So I'm going to solve these just like normal. Y plus 2 equals 8. I'm going to subtract 2 from each side. I end up with y equals 6. Other side, y plus 2 equals negative 8. Those cancel. Negative 8 minus 2 is negative 10. So my two answers for this are 6 and negative 10. If I go back and plug it in, it makes sense. 6 plus 2 is 8. Absolute value of 8 is 8. Negative 10. Negative 10 plus 2 is negative 8. Absolute value of negative 8 is positive 8. So this is one where we would have two solutions because we can turn 8 into a positive 8 and a negative 8. The first one that we did, we can't turn 0 into a positive 0 and a negative 0, so that doesn't work. All right, number 3, kind of a weird one. I have a negative 4 out here. So remember how I said before we started the last equation, the first thing we need to do is get rid of everything besides the absolute value bars. So this needs to be by itself, the 7 minus 6k. So I need to get rid of that negative 4 times that. And since it's negative 4 times that, I'm going to need to divide both sides by negative 4. So then I end up with absolute value of 7 minus 6k. 14 divided by negative 4 is negative 3.5. Okay? We have an issue here. We have the absolute value of something equaling negative 3.5. That is not possible. Remember, we can't go negative here. So if you ever get to this step where the absolute value is by itself and it equals a negative number, we're done right there. We can't do anything. The absolute value can't be a negative number because the distance can't be negative. Okay, let's look at number 4. 4 has d divided by 3. Absolute value is already by itself. I like this problem. We don't have to do anything. Equals 3. Again, we like this problem. It's a normal problem. I can have a positive 3 and I can have a negative 3. So I'm going to write that. So d divided by 3 equals positive 3. Then way over here, I'm going to do d divided by 3 equals negative 3. So notice how I wrote two problems, one with a positive answer and one with a negative answer. And then I should have wrote this a little over because now I'm cramped over here. So it's divided by 3, so I'm going to times by 3. So d equals 3 times 3 is 9. I'm going to go over here. Same steps. It's divided by 3. So I'm going to multiply by 3, except now I have a negative 3. So negative 3 times 3 is negative 9. So my two answers then are negative 9 and positive 9. If I go back and check that, 9 divided by 3 is 3. Absolute value of 3 is 3. Lots of 3's in this problem. And then negative 9 divided by 3 is negative 3. And the absolute value of negative 3 is positive 3. All right, 5 looks a little more complicated. Again, remember I said our first step is to get the absolute value by itself. Well, 2x minus or plus 5 is in the absolute value bars, but I got this 3 hanging around here. I got this 10 hanging around here. So I got to get rid of those before I can set up my two equations here. Okay, so I have plus 10 here. So I'm going to minus 10. So I have 3, 2x plus 5. 37 minus 10 is 27. Divide by 3, because it's times 3. Divide by 3. So I end up with 2x plus 5. 27 divided by 3 is 9. Okay, now the absolute value is by itself. Now we can write out our two problems. We're going to leave that over there as our one problem. Oops, let's do this in red, not black. So 2x plus 5 equals 9 is over here. So this side, I'm going to write 2x plus 5 equals negative 9. So wrote out the same equation, equals a negative 9 equals a positive 9. My steps are both the same. Minus 5 minus 5. So 2x equals negative 14. Divide by 2, divide by 2. X equals negative 7. Over here, the plus 5, so I'm going to minus 5. 9 minus 5 is 4. Divide by 2, divide by 2. X equals 2. So here we have negative 7 is one answer. Positive 2 is another answer. Okay, so before we go on to our last kind of problem, I want to just make some steps here. So step 1, make sure you have the absolute value bars. Get absolute value bars alone. That should be our first step when we're solving these problems. Get the absolute value bars alone. So if you go back and look at these problems, wasn't an issue in number 1. Absolute value bars are alone. They're the only thing on the left side of the equation. So we just started the problem. Number 2, same thing. Absolute value bars were alone. So we can just start the problem. Number 3, we had to do some work. We had to get rid of that negative 4 before the absolute value bars were alone. Number 4, we liked absolute value bars were alone, so we can just set up the 2 problems. Number 5, it's kind of a pain in the butt. We had 2 things on the outside. We had the 10, we had the 3, so both of those needed to go away before we can set up our 2 problems. Okay, step 2. Set up one problem with a positive answer. Okay, so just like when we went back, we'll go back again and show you. Okay, first problem, we couldn't really do this because it equaled 0. 0 is not positive, 0 is not negative, so we couldn't do that. Here we did. We set it up, y plus 2 equals 8. This problem, we couldn't do it because there was no positive answer. It was negative 3.5. So once you get to step 2 and you realize, that's not possible, you're right, it's not possible. That's why it's a no solution. We did it here with number 4. D divided by 3 equals 3. And we did it here with number 5. 2x plus 5 equals a positive 9. Okay, step 3. We're going to set up one problem this time with a negative answer. Let's go back and look at an example of how we did this in the problem. Okay, couldn't do this on number 1. We had 0. There is no such thing as negative 0, so that's not possible. Here, we did it here. Equals 8, so we made it equal a negative 8. Here, it was already negative, and we can't do that, so that's a no solution. Here, it was equals 3, so we made it equal negative 3. Here, it equaled 9, so we made it equal a negative 9. Okay? Then our last step is to solve each equation. Okay? Well, I guess we have the 5th step of graph, but graphing, we're just putting a dot where it is. Okay? So we're going to solve each equation in graph.